Hello everyone, this is Pruthvi Manjunatha. The product that I'm going to present today is a simulation extension with CAV functionality for VISSIM. This product was developed on a strike project along with my co-principal investigators, Dr. Elefteriadou from University of Florida and Dr. Michael Hunter from Georgia Tech. So the big picture for this product is that there's significant improvements in autonomous vehicle technology as well as their connectivity and interaction with the future generation traffic system. So this is expected to create a perfect storm in how vehicles navigate through cities, roads, and highways. So this brings us a challenge of of answering many what if scenarios to be considered. Specifically for this project, we consider for this product, we consider how CAVs impact traffic management and emissions. So our solution to this challenge was to come up with a microscopic simulation extension for VISSIM, VISSIM being the most used commercial, widely accepted simulator, to develop an extension that evaluates traffic operational quality as well as emissions in the presence of CAVs. So to implement this solution, so we use two key components of VISSIM. Those are COM application programming interface and external driver model. So COM application programming interface is very useful, in extracting all sorts of data from the simulation environment, be it traffic data or the signal status, etc. So we use a COM API to get that data, and COM API interacts with AV or CV logic to demonstrate how the product works. Like we used a couple of AV and CV models from the literature. So the COM API pushes all the input data into the logic, and it takes the estimated accelerations and puts it on a text file. And the external driver model's strength is implementing the acceleration for each vehicle accurately in VISSIM. So the EDM picks up these estimated accelerations from the text file left by COM API and implements it in VISSIM. So this is a simulation implementation. So this was coupled with an emissions implementation where the trajectories were extracted in a 1 Hertz frequency, and they were ran through the MOVES model to come up with various greenhouse gases. On the right, you can see some of the example graphs or plots of how the speed can change for different penetration rates and for different saturation rates. And you can also see some box plot down here for the emissions. So overall, we expect the impact of this simulation extension to be once it gets adopted widely by the CAV researchers and the simulation modeling community, this would enable wide scale assessment of how CAVs can impact traffic and congestion and emissions. And also, as a future work, we are doing it on another strike project currently, is that when you couple this kind of a framework with an optimization setup, we expect and if the one of the optimization criteria are to limit or reduce emissions, we expect impact of such a implementation to also reduce the impact of emissions on climate change, for example. With that, I'll leave you with the contact information for myself, and feel free to reach out to me to get the product and give it a test ride. Thank you.